Thank you, Lean, and thank you so much to everyone for being here today. As Lean said, my name is Jessica, and I'm here on behalf of iMotions, and we'll get a little bit into what iMotions is and what we provide. And as she mentioned, I do have a background in neuroscience. A lifetime ago, I used to study Parkinson's disease, but in the 4 years that I've been with iMotions, I've had the unique opportunity to explore how we can bring neuroscience tools to other areas of research. Education is definitely one, but also ranging from communications, media, and many other verticals in the commercial space as well. So I'm very happy to be here today to talk a little bit about the possibilities for our online data collection tool within the sphere of education. So very briefly, just an introduction to what is iMotions and what we provide. So I know many of you are familiar with biosensor tools already, either just through hearing about it or through your own research. So eye tracking is definitely really popular, as well as facial expression analysis. We'll talk a little bit about those today, but also other tools, including heart rate and skin conductance and so on. And for those that have worked with these tools, the main challenge is bringing all of them together into a single place. More often than not, we're getting sensors from different vendors, and the challenge is really synchronizing and integrating all of these inputs. So what iMotions provides is a single software package that integrates and synchronizes these multiple inputs into a single platform where you can collect data, analyze the data, and see everything all in one place, even though the sensors are coming from different sources. So not only can you collect the data, but we can also replay the data and have options as well for analysis and export. So first and foremost, we are a software company. Our platform is basically an end-to-end experimental platform, and you'll actually be able to see that later in the talk today. But we also are third-party resellers of the sensors and hardware. We also provide support for those. And then finally, our support and services is really where we hang our hat. We really pride ourselves on the education and training in the use of these tools and what they can provide. Many of the people on our staff have advanced degrees, so we really understand the challenges that you go through with your research, and we want to try and help you be successful as best as we can. So now that the pitch is done, let's go into the actual meat of the talk. Just very briefly, we do have over 1,200 clients worldwide. It's a pretty solid split between academic clients, and like I mentioned, this is across multiple departments, including education, communications, business, and so on, but then also within the commercial space as well. So let's take a step back and think about what's gone on the past year in terms of research and sort of what's going on in the world today. And I know that, in the US and in Europe, we're still undergoing vaccinations and all of that. And then there's other flare-ups happening in other areas of the world, like India and Ontario, for example. So we're not entirely out of the woods yet in terms of the pandemic, but let's just sort of take a step back and think about how things have changed within the research landscape and what we've done to sort of overcome or adapt to these, and what that might mean for us in the short-term future. So the biggest change educators have had to deal with is this drastic transition from face-to-face education to online distance learning. This is a report from UNESCO that showed that as of April 2020, so right when the lockdown really started, 191 countries had closed their schools, affecting approximately 91% of students. So this slide here is from their report. If you actually visit the slide deck, you'll be able to toggle between the different education levels here. This is just showing primary school at the moment, but it really shows the distribution of how we've adapted to other technologies when we can't have people or students in the classroom. You can see a lot of these adaptations, if you look at the purple bars here, are for online material as opposed to TV, paper, or radio. So of course, this is a huge transition across the board for educators as well as students, and different ways of us trying to sort of adapt to these different technologies. Now, although these adaptations have been really challenging, I always like to say there's opportunity in the challenge. So this has been sort of described as the opportunity to have large real-life laboratories for experimenting with distance learning practices and paradigms. And these sorts of challenges and opportunities span multiple facets in sort of what we're going through right now. And so I've tried to sort of compile a list of ways in which we can think about distance learning, the kinds of questions that we can probe, and the challenges that we're sort of seeing now across the world as people are trying to sort of adapt within this new paradigm. So student monitoring is something that obviously makes a lot of sense. One really good quote here from one of the papers cited is that there's now a physical and psychological separation and distance between teachers and learners, and even among peer learners. And obviously that's going to have huge implications for student engagement, not just with the teacher, but with each other. And I'm sure a lot of you have already seen that when you're trying to teach classes over Zoom. A lot of the students are going to have their cameras will be off, or their hands will be on their faces here, just sort of looking really bored. I've seen that too in my own lectures that I've given to students. And I thought, it's understandable for students to be bored during a lecture, but this is a whole nother level with Zoom fatigue, right? So this is absolutely an issue that we're seeing now in education that we need to spend a little bit more time looking at, not just with students, but also teachers. For many teachers, this kind of shift to distance learning has been a pretty big change for them, moving to Zoom especially. So for teachers, we need to think about how do we best support them in learning how to use these novel technologies and having to adapt their own curricula to these online formats in a way that is still engaging to students and still accomplishes their educational objectives. From there, we can look at different approaches to education. So synchronous versus asynchronous, for example, there's a whole body of literature looking at these kinds of approaches to education. And obviously now with distance learning and MOOCs, especially in online courses, we're seeing a lot more of these asynchronous approaches. So what does that necessarily mean for education and retention? From there, there's also the usability of online material. So how do people engage with video formats versus print formats versus interactive web-based sort of material? If we make improvements or iterations to these kinds of material, how does that change user engagement? And then finally, sort of looking more broadly at the opportunities that are now available with these sort of distance learning approaches that are now unbounded by geography. So some teachers have sort of taken the initiative and thought, how can I best capitalize on these new approaches? Because now inviting expert guests to come and give a talk to your class is a lot easier when it's done over Zoom versus having someone come physically into the classroom, or being able to engage with students or other classrooms across the world or across the country. All of that is a lot easier now that we're dealing with online approaches. So not only are there challenges, but there's also new ways in which educators have had to adapt. And these are all things that we can try and study in further detail and see how has that changed education for better or worse? How does that change student engagement for better or worse? Now, if we step away from the classroom and away from educators and now look at the people who research education, we also have had to undergo our own paradigm shifts, right? And that now we can't bring people into an actual physical lab space. Typically a lot of the labs that I see are in a central location where you're bringing people into a physical space, especially if you're using biosensors and sitting them in front of a computer with all of the equipment and having these really nice controlled experiments. And now no one has been able to do that, to be able to go into a lab, to be able to bring people in. It just hasn't been possible with the pandemic. So now there's been this increased need and demand for remote solutions. So that's one challenge. But again, there's opportunity in that challenge, right? Even bringing people into a controlled space has its drawbacks. For example, if you're bringing people into a lab space, there's always going to be the effective experimenter bias and always the question of ecological validity. Is what you do in a controlled lab space the same as what you're going to see in the classroom? Even for those who decide to do classroom monitoring and actually go physically into a school, you're still pretty much limited by geography, right? More often than not, you're going to go to a school that's close by, and the results that you have are going to be pertinent to that immediate vicinity, but might not be valid for other countries, other communities, and so on. So within that, again, there's sort of this opportunity of, if we were to adapt our methods to something more remote, then there's sort of this opportunity to collect data from people's homes, which, they're going to be at home anyway, but then also we can have this opportunity to sample from a wider population and sample from a much more varied data set to really drive some broader and more interesting insights. So if we take these two sides, what the educators are doing and what the education researchers are doing, we end up with this sort of nice convergence here. So we're moving from classroom learning to at-home learning. Meanwhile, for educators, we're moving from in-lab research to remote research, and all of it sort of converges in the home, which is, in a way, kind of really nice. Again, there's opportunity in this. So how can we best leverage technology to be able to study these new paradigms in a way that is valid and in a way that sort of leverages the advantages of the situation that we're now in? So having painted sort of that landscape, right, let's go a little bit into the tools that we have available. So what I'd like to do for the rest of the talk is introduce our remote tools within the iMotions platform. So we'll go through a review of facial expression analysis and webcam-based eye tracking. I know several of you have worked with these sensors before, so this might be old hat for you, but we'll go a little bit over the theory and what that means. We'll do a quick demo of the software and the online data collection module that we have and go through the results of that sample study that some of you participated in when we sent the link out with the meeting invite. We'll go over some caveats, so study design considerations. What do you need to think about when you're designing studies with these remote tools, and how does that differ from bringing people into a physical lab space? Then we'll go through some sample use cases, and then at the end have time for Q&A. So let's get started first with facial expression analysis. The facial action coding system is sort of the gold standard for qualifying facial expressions, and this was first published by Paul Ekman in the 70s in the psychology literature. And the way the FACS system worked originally was it employed human coders that were trained in the FACS system, basically going frame by frame through video feeds and quantifying these discrete individual movements of the face called action units. So some of the action units are listed here in this example. So things like inner and outer brow raise, brow furrow or lower, lip stretch, jaw drop, and so on. So there's like a whole system of action units. And you could look at when these action units occur separately and in combination to each other. And it ended up being a really good system for a couple reasons. First off, it's non-intrusive. You're just working with video feeds of people. It's an objective scale of the activation of these action units, and it ended up being really reliable and having high validity. But there's also some drawbacks to this approach, primarily in that it's extremely labor intensive. For a FACS-trained human coder, it can take about 100 minutes to code for 1 minute of video. So you're going frame by frame, usually through this high quality, high frame rate video, which takes a lot of time. And even the act of becoming trained and certified in the FACS system is also extremely labor intensive. It requires about 100+ hours of self-study. The exam itself can take up to 12 hours. I've been very lucky to get to know a couple of FACS-trained researchers in my time at iMotions, and across the board, they say the experience is grueling, just the act of learning how to code for these facial units, and then finding out that no one else is really certified in the FACS system, so they end up doing a lot of this work in the lab by themselves. So there's a lot of demand now for automated versions of the FACS system, now that computer vision and machine learning have become a lot more prevalent in the tech world today. So there are several engines out there on the market, but the one that we work with is called AFFDEX, which is by a company called Affectiva. So Affectiva originally spun out of the MIT Media Lab. So this was born out of academic research, and there's a whole publication list about their algorithms, but now is being spun up for research and commercial purposes. We'll go into the engine itself and sort of what it does, and you'll be able to see it live. But in short, what it does is it takes a video feed, isolates the face, and based off of the changes in the movements of the face, outputs probabilities of what facial expressions are made at a given time. Now, the quality of an AI is about as good as the data that you use to train it. The wider the data set and the higher quality of the data set, the better the algorithm is going to be at giving you accurate information. So with the AFFDEX engine, they actually boast the highest or the largest training data set out of all the engines on the market. It's based off of 6 million faces from 87 different countries. So what happens is that countries all over the world, people send their videos to the Affectiva developer office, and those videos are evaluated by 3 FACS-trained human coders for the quality of the data before it's used to train the algorithm. So as a result, the data that's used to train the AFFDEX algorithm is sort of evaluated according to FACS standards, so qualifying according to the action units and by FACS-trained human coders, thereby ensuring that the data that you're getting with the AFFDEX engine is still sort of bridged to the FACS system, which is this gold standard that you see in the literature, right? So it's according to those academic gold standards, and then that way makes it a little bit more academically validated. So there's a couple of links here if you're interested in their specific metrics and also in the publications that employ AFFDEX. We also have several papers on our own website, if you look at iMotions.com, of people who have used AFFDEX with iMotions and published. We have a couple of links there for you as well if you're curious. But what you eventually get out of the engine is something akin to this. So these are sort of snippets from our replay editor, and again, you'll be able to see this later on in the talk. But what you're able to see is a continuous time series of what facial expressions are made at a given time while someone is undergoing some sort of an experience. This could be a video, this could be a website, this could be an image, or any other sort of interactive material. So you can basically see at what time someone is showing a smile or furrowing their brow or exhibiting any other sort of expression. Not only can you record these live, but you also can analyze videos that you already have. And this is something that we see a lot for people that have recorded sessions, say via Zoom. So we see this a lot, especially in sort of tutoring scenarios where you might be tutoring a student over Zoom and you have this recording and you want to see what kind of facial expressions your participant was making at a given time. This example on the right is an example of a Zoom recording that we did with 5 people just in a regular Zoom call. And we did a screen share and just showed people just a series of videos. Taking the recording from Zoom, and it could be GoToMeeting, it could be WebUX, any of these sort of video conference programs that you have that can record meetings. We can take this recording and actually run it through the facial expression engine and sort of pick which face you want to analyze. So we can actually get facial expression data from all 5 participants in the group and then be able to plot that in time with the recording. Again, we'll see a little bit more of an example of this later on during the live demo, where you can see some facial expressions live as well as from the replays. The second sensor is webcam-based eye tracking. And this is something that we've kind of shied away from for a while because here at iMotions, we always are proponents of the infrared eye trackers that you use in a physical lab space. But of course, with the pandemic and the conditions that we have now, there's been an increased demand for these sort of remote tools, including tracking the eyes using a simple webcam. So there are many sources of webcam-based eye tracking algorithms out there, and we have our own that we'll show you. But the premise behind all of them is pretty much the same. You have a webcam video feed, and what the algorithms do is employ computer vision to detect the face and extract certain features, in this case, the position of the iris and the pupil as they move around with the eyes. Based off of a calibration that you do, and we'll talk a little bit about calibration later on, we're able to position or sort of map the position of the eyes onto the screen and get a sense of where people are looking on a screen. And here are some sort of sample metrics down here on the bottom. These are heat maps that show aggregations of visual attention. This is actually an internal study that we did, not in education, but in political science. So what we did is we had groups of liberal versus conservative participants looking at polarizing images. So in this case, this is a Black Lives Matter protest in the US. And what we can see from the heat maps is that liberal versus conservative groups show very different patterns of visual attention when shown the same picture. So for example, liberals tend to focus more on the weapon here in the photo, whereas conservatives tend to focus more on the protester. So that's one example from political science. We'll see some other examples of that with our sample study today. So with that, let's go into the software itself. We'll do a quick tour of the interface just to orient ourselves, and then we'll go through what I went through in setting up that online data collection study and go through the data that all of you helped provide when you ran yourself through the experience. So I'm going to exit out of this PowerPoint and go to the iMotions platform. Okay. So this is the main iMotions desktop platform, and everything begins and ends with the desktop platform, not just for designing your study, but then also analyzing your data once it comes back from the cloud. So we'll go through each of these different panels. On the left here is your library. Any studies you run will be listed here along with any analyses that come from those studies. So we'll have some examples of that in a second. Up top, we have our stimulus timeline where I basically design the study and what everyone would be seeing as they go through the experience. So for those who have actually gone through the experiment, this is all the stimuli that you saw. For those unfamiliar with the study, we have a couple of instruction slides here, just giving some basic sort of instructions. We have our calibration slides, and we'll go into how important these are for the eye tracking in a second. And then we had 3 core stimuli here. We had an infographic image that people were exposed to for 20 seconds where they could just read at their leisure. We had an informational video about vaccines and how they work. And then to assess learning and retention, we had a really quick Qualtrics survey here at the end with a multiple choice question, just probing them on the material from the infographic and the video. At the end, we have a second set of calibration slides. And again, we'll get into why these are important here. Now, for me, as the experimenter, if I've gone through and set up this study here, with the online data collection platform, we can design studies that include images, videos, and websites. Within the iMotions desktop platform, if you're bringing people into a lab, there's many more options available like phone and tablet and VR. Obviously, that's not applicable here. So images, videos, and website stimuli can be incorporated into my study. Once I've designed my study with the different stimuli that I want, and I've settled all of these other variables like randomization, exposure time, block designs, and so forth, once I'm ready to distribute my study, I just have to right-click on my study and go upload to iMotions Cloud. What this is going to do is take all of my stimuli, zip it up, and send it to our cloud service, which is located here at my.imotions.com. So each iMotions user has their own version of my.imotions that is tied specifically to their license. So any studies that they upload will be strictly available to their version of my iMotions. We don't see any of it. Any other users don't see any of it. Similarly, I wouldn't be able to see any studies that any clients have uploaded. But we have many studies here that we've run here in the iMotions office, so there's lots to choose from. But this particular study that I've uploaded is accessible here. If I click on my study, you basically get this little interface where I can see sort of the number of respondents that have already gone through the study, the kinds of stimuli that are available. And if I go to details here, this is where I can set up the different options for my study and how I want it to be presented to people. So there's a couple of quality control sort of checks that I can include. If I want to record the participant's microphone, for example, so say I have students that I want to have sort of as a talk aloud going through the material verbally, and I want to record their microphone in addition to the webcam, I have that option here. I can do microphone checks, audio output checks, especially if I'm showing video. There's also a couple of quality control checks I can do, so head position, eye detection, and so on. For those that have gone through the study, that's sort of that little interface where it shows you, your head position in the camera to make sure that you're front and center and that we can actually see your face and eyes accordingly. These redirect options down here are especially useful. So one of the challenges with online data collection is in recruiting participants and having a streamlined funnel of participants going through your study. And a lot of people will use online panel services to handle that recruitment. So Prolific is one such example that's really popular. There's also Amazon MTurk, Decipher, any other sort of panel services out there. So say, for example, you're recruiting participants, you have them go through their your study on the iMotions platform, and you need to redirect them to an external page for compensation or any sort of wrap up for the study. You can actually redirect people from the end of your study in here to a compensation page, for example. So we have the ability to embed our online data collection tool within wider panel sort of recruitment infrastructures. And we've had people, clients working with multiple panel providers, including sort of our ODC studies within those infrastructures here. Once I've set up my study and I've decided it's good to go and I'm ready to distribute it to my participants or my students, all I have to do is click Start Remote Data Collection. So what that's going to do then is give me a link, which I can then distribute to my participants. And I can distribute it however way I want. I can send it over email to people. I can send it again through that panel provider. The URL is the exact same for everybody. So I'm not going to go through the experience here because I know several of you have already gone through sort of the experimental protocol and what that looks like. But for those who go through the experience, it basically opens up with a splash page of, welcome to my study, and will basically walk you through the steps of setting up your webcam, setting up your screen share in order to best prepare you for the study. And then all the stimuli are shown on full screen. You're able to see that, and then the study will automatically end and save all of the data to the cloud. Now, for the experimenter, all of you, you have the opportunity to monitor the progress of your study as it's happening. So you'll notice here, if I go down to sessions, as each individual completes the study, you'll be able to see that session as it's completed. So this individual started the study at this time, ended the study at this time, their data was successfully uploaded to the study, and then we also have some quality control metrics. So we have the percentage of frames in the video where the face was correctly detected, and then we also have some eye tracking accuracy metrics. So we have accuracy in degrees here, sampling rate, as well as the quality of the data in terms of how much data was successfully collected. So we can just leave the study open and people can click on the link at their leisure, do the study at home within the comfort of their own environment, and then you'll be able to sort of monitor people as they're coming in. Now, once you decide that I have enough participants, it's time to download that data and analyze it afterwards for reporting. All I have to do is click this download zip file button here. What that'll do is it'll take everyone's data and everyone's webcam recordings, integrate it into a single zip file, and you can download that and re-import that back into iMotions for analysis. So that's actually what I have here. So we successfully collected 7 people from our sample study leading up to today's webinar. So thank you to everyone who participated. And if I click on one of these individuals, I have the opportunity to go to our respondent panel and fill in any pertinent information about that person. So if I want to change these unique identifiers, I can. If I want to add additional information like gender or age or any sort of custom group for a between subjects design, I can do that here. This will give me the opportunity later on to run custom segmentations of the data. So say I want to run separate analyses for males versus females, or for groups for different age demographics or different grades in school. I can absolutely do that segmentation when we create our analysis. But here's where I'll also get access to our data replays. So if I click on the infographic, for example, for this person, this will open up our replay editor. And again, this is where we'll be able to see everything all in one place. So we have the stimulus here that was shown at the time. So this was our infographic on vaccines that was exposed to people for 20 seconds. We have the webcam here of our participant. And if I actually play the replay, we'll be able to see the data coming in from the webcam-based eye tracker. So that's this little dot that's moving around. And then you also have the face box here that's shown for the facial expressions. Now, if I go through this panel here on the left, we can toggle between our different options. So I can easily move between participants. I can easily move between our different stimuli here. Under visualizations, I have a couple of different ways in which I can look at the gaze data. So right now, this is a gaze replay that's being shown over time. If I want an entire gaze path, I can define that here with static here. So we can see that a lot of her concentration was devoted here to the bottom corner of the text. I can change the colors if I want. If I'm interested in things like fixation order, I can toggle that and we can get a sense of where she's looking at a given time, starting at 1, 2, 3, 4, and so on. Right now, fixation duration is shown by size. We can also do it by color, which I think is a little bit nicer, a little less obtrusive. If we're dealing with image stimuli, you can also derive mouse behavior as well. So clicking, mouse position, and so on. If I go to signals, this is where we can look at the facial expression data. So anything labeled AFFDEX here is coming from the webcam, and this will be where our facial expression data lives. There's actually several levels of detail that you can get into. You actually get a lot out of AFFDEX, and it's sort of intimidating, sort of picking and choosing what metrics work best for you. But there's sort of different levels of detail depending on what you're interested in. At your base fundamental level, you get 20 of what are called action units. So these are specific individual movements of the face. AFFDEX also gives you scores for your 7 core emotions. So anger, contempt, disgust, fear, joy, sadness, and surprise. For many people, they're very happy with the facial expression action units because they're extremely sensitive and specific to those discrete movements of the face. For example, brow furrow is a really great indicator of just negative valence in general. So confusion, frustration, anger, trying to read something. And I can basically toggle the different metrics that I'm interested in and plot that over time. And again, I can basically go through the replay and see what it is that she's looking at. And if there's a particular brow furrow reaction that I want to reference, I can see, okay, there was a little change in activity here. This is what she was looking at in the moment. Now, these individual replays are extremely valuable, but a lot of your insights are going to come from aggregates. So what everyone is doing at a given time. So if we go into our analysis here, We can actually derive heat maps, right? So we went over these earlier that show the visual aggregation of all of our participants as they're looking at the infographic. So we can see that the text here in this case attracted a lot of visual attention. There's only some sort of cursory search behavior here for the images. A lot of attention was focused here on the text. We can also draw areas of interest. So say we need to get some quantifiable metrics here. We can basically draw areas of interest around the different elements that we want to derive metrics for. So I'll do some for text here. And then I'll very quickly calculate some metrics. So with the areas of interest, you also get a lot of different metrics out of it. And we'll go through a couple of them that are most relevant. But the ones that we most commonly see are hit time. So this is essentially how quickly it took people to attend to one box versus the other, and we see that here in milliseconds. So people attended to the first block of text first, followed by the second. We can also get dwell time. So how much time did people spend in one area of interest versus the other? And we can also get a respondent count or respondent ratio. So how many people attended to one versus the other? And this gives you a great sense of what's drawing attention first, what's maintaining attention, and how many people are looking at one element versus the other. Are there certain things in your infographic that are getting ignored? We can also look at aggregates for the video and isolate specific events such as the number of people that showed a brow furrow at a given time. So I'll pull up this aggregate here. There. And if I pull up brow furrow, what this shows here is the number of people that exhibited brow furrow at a given time while watching the video. And then you also get the aggregated gaze data here. So you can see that, it's doing pretty well in terms of being able to track the text, looking at the different images and so on. And these visualizations are obviously available in the replay, but then they're also available in the text exports here, where you can basically download summary metrics for your areas of interest. So your dwell time, hit time, and so on in a text file. You can also get your facial expression content here in terms of the % time spent showing a particular expression. So if you're doing a comparison of different conditions, for example, you can say, okay, condition A showed people with 10% of time spent in brow furrow compared to 20% for the second video. So that's an easy sort of export that the software can provide. And all of our text exports are tab delimited text files or CSV files. So really easy to import into Excel for any sort of analysis, but also just as easy to import into SAS, SPSS, MATLAB, any sort of program you'd like. So I'm going to breeze very quickly through the rest of these slides because I know I want to save some time for Q&A. But what I want to do is get a little bit into study design considerations. Now that you've sort of seen what the data looks like and what it can give you, there's ways in which we have to think about these sensors in order to maximize, the quality of the data that you're going to get. And the subheading for this is webcam-based measures are not for everyone. There are certain caveats with the technology that you have to keep in mind as you're designing your study and ensuring that the data that you're going to get is going to be viable. So what this slide intends to demonstrate is sort of what the camera sees when we're trying to log webcam-based eye tracking. If you're using an infrared tracker in a lab, that data is actually really simple. The infrared tracker is sending infrared light into your face and actually looking at the reflection of that infrared light off of the cornea. So it's really just looking for that infrared speck in the camera, which is very easy to detect. With webcam-based measures, it's a little bit more complicated because we're using computer vision to detect the eye, detect the features of the eye, and then look at the pupil in the iris and determine position of the iris relative to the areas on the screen. That's a lot more complex and a lot more difficult. And what this slide demonstrates is that there's a lot of variability in the kinds of features or the kinds of video feeds that the algorithm has to contend with. So you might get a video feed that has a very clear eye like this with a very clear pupil, very clear features. This eye would be very easy to track. Whereas some of these other eyes are a little bit more ambiguous. Either it's more difficult to see the pupil, or even the features of the camera just aren't all that good to begin with due to poor lighting or poor camera resolution. So what that means is the quality of your data is going to be a lot more variable compared to if you were using an infrared tracker. This is best exemplified using this graph. The two elements that are going to be a little bit more compromised when using webcam-based measures are yield and accuracy. In terms of accuracy, what you're going to get is sort of a wider spread in terms of degrees of what your eye tracking accuracy is going to be. If you're using an infrared eye tracker, the actual hardware, a Tobii tracker at its very best has an accuracy of 0.3 degrees, which is really good. However, for a webcam-based measure, the best you're probably going to get is around 2.5 degrees. And that would be considered good accuracy for a webcam-based metric. So just due to the nature of the algorithms themselves, your accuracy is not going to be the same as if you were using an infrared tracker. And it's one of the reasons why we sort of shied away from webcam measures to begin with. But now sort of with the way the pandemic is, there's sort of this increased demand for these remote measures. So that's really something to keep in mind. The other dimension is yield. So when you're bringing people into a central location and doing your eye tracking testing there, a lot of things are controlled. The lighting is usually controlled for everyone. Everyone's seated in front of a desktop computer and not moving with the infrared tracker and the camera in very specific places. So the quality of your data is going to be a lot more consistent. For an infrared eye tracker, you can count on 90 to 100% of your participants yielding good data, provided the calibrations are good. With webcam-based eye tracking, by virtue of literally collecting data in people's homes, there's many more moving parts. The lighting conditions from person to person are going to vary significantly. The sampling rate of your webcam might be 15 frames per second. It could be 30. People, a lot of the time, are not going to be seated in front of a desktop computer, all nice with good posture, seated in front of the webcam head on. A lot of people are going to be on the couch with the laptop on their knees. Sometimes you're going to get people eating during your study. You're not going to be able to control for that. So simply because of all of these moving parts, you will also have to assume that your yield, the number of participants that are going to yield good data, is going to be a lot lower as well with webcam-based eye tracking. If an infrared tracker yields 90 to 100% participants with good data, assume that with webcam-based eye tracking, your yield will be about 20% at best. So what that means is you will have to compensate for this decrease in yield and accuracy with an increased sample size. And we'll see an example of this later on with the use cases. But basically what this graph shows is that with normal eye tracking, with an infrared tracker, you're going to get very high accuracy and very high yield. If you have a population that's really compliant, that follows instructions well, has good lighting conditions and good calibration, you might end up with decent accuracy and yield for a webcam-based measure, but more often than not, your webcam eye tracking is going to be down here in the bottom corner. And that's not a commentary on one algorithm versus the next. It's really the nature of the beast when it comes to this technology and the nature of the algorithm itself, because it's naturally going to be more complex and you have more moving parts and less control over your experimental conditions. On top of that, there are additional moving parts with regards to study setup that are also going to affect the ability of people to yield good data. So if you're dealing with browser issues, for example, the online data collection tool is browser-based, so there might be compatibility issues with the browser or the webcam, bad lighting, internet issues as well. If you're dealing with populations that might not have the best internet access, that can also be a variable in people not being able to yield good data, as well as video encoding issues. So again, many more moving parts you have to keep in mind since you're not in a controlled lab environment. And again, you will have to compensate for that by oversampling and having a larger sample size. Now that I've gone through all of these sort of depressing issues to think about, you might be asking, well, what can I actually do to maximize data quality for the people that I do get? And there's a couple of things that we can do. The first is eye tracking calibration. So for those that have used eye trackers before, you're probably familiar with sort of the crosshairs that move across on the screen that you have to track with your eyes. For those that have gone through our online data collection study leading up to today, you've also seen something similar with those little crosshairs moving across the screen. Those are calibrations that map your gaze to the screen and that the algorithm uses to ensure best accuracy for the study. This is a graph from our own internal testing in-house that shows that the more calibration phases you include in your study, the better your accuracy is going to be. These two bars here on the left are if you included a calibration phase at the beginning of your study or at the end in isolation. Whereas if you had calibration slides at the beginning and the end, as well as inner slide stimuli in between, then your accuracy improves to around 2.3 degrees. So this is about the best that it's going to get for webcam-based measures. And again, that's something you have to consider when you're designing your study. Ideally, your study would look something like this, where you would have instructions at the very beginning, your first calibration phase or your set of calibration slides at the beginning, and then following up with the different stimuli that you have, whether it's videos, images, websites, interviews, any of those sorts of things, with calibration slides in between, and then finally a set of calibration slides at the end. Each calibration phase adds about a minute to your study design, so it doesn't add all that much, but it is still something that you have to keep in mind while building out your study. And then finally, being able to give good instructions to your participants is also going to be instrumental in yielding good data. So educating your participants and making sure that the lighting is good and consistent in the home, that you have good ambient light that doesn't wash out the face, but also doesn't leave the face too dark either. For those that wear glasses, glasses can also be a source of glare if the monitor is reflecting light off of the glasses that can impede the camera's ability to actually see the eyes and track the eyes. So if possible, try to avoid people wearing glasses during these studies. Not moving during calibration, using a proper external webcam with a high enough frame rate. These are all things that you can screen for at the very beginning and also provide in the instructions leading up to executing the study. So with that, trying to be mindful of time here, we have a couple of use cases just to show you sort of these tools in action, and then we'll head into the Q&A here. So the first example is one of our clients. So this is the University of South Florida. So this is actually within the School of Advertising. So they have communications and media and advertising researchers within this space, but they have a Center for Marketing and Sales Innovation that uses iMotions tools to assess how people respond to different messaging and creative. So this can be images, videos, websites, and so on. With the pandemic and with the online data collection tool, they actually embarked on a collaboration with Baycare Health System to look at how people respond to COVID-19 related messaging. So Baycare provided creative in terms of videos and images and infographics about COVID-19 preventative measures and vaccines. And they also provided participant pools for USF to leverage for this study. So they were able to use the online facial expression and online webcam-based tools to look at how people look at COVID messaging in their own homes and see where are the points of engagement, what are people looking at, and what elements might be confusing or frustrating to the participant. Another example that's a little bit more education focused. So this is a paper that came out this year in PNAS looking at webcam-based eye tracking while people were watching educational videos at home. As sort of a testament to the oversampling that's required when you're collecting data at home, this study had over 1,000 participants that were recruited using Amazon mTurk and Prolific to watch YouTube videos at home while a webcam-based eye tracking algorithm was active. What they found was really interesting. They found that for students that were engaged while watching educational videos, more often than not, they had synchronized eye movements. So they all tended to follow the same pattern of looking at different features in the videos. So subjects 1 and 2 here that are shown in yellow and red show very similar patterns of horizontal and vertical gaze while watching the video. Subject 3 was a little bit less engaged, and you can see that their gaze data is actually very different from that of subjects 1 and 2. Not only are more engaged students showing similar eye movements, this is also reflected in their quizzes and their retention of knowledge after the fact. So this was an educational video about why are stars shaped like stars? That was literally the title of the video. But there was a quiz afterward testing their knowledge. Subjects 1 and 2 in yellow and red ended up doing really well on the quiz, whereas subject 3 that showed very little engagement according to the gaze data ended up not doing so well on the quiz afterward. So this shows a really interesting example of how the method in which students attend to certain educational material can have direct implications for how they perform, and that there is a consistency across the student pool and how they respond to educational collateral and what that means for their results, and that it's actually a good predictor of learning performance. So that article was published really recently in PNAS, really interesting results there. So quick summary. I know I've thrown a lot at you today, so I'm really eager to answer any questions during the Q&A, but just to summarize the points that we've made through the past hour. So moving to online distance education is something that we've had to do over the past year, and it really comes with its own set of unique challenges. And this can be according to students, according to teachers, comparisons of teaching method, the usability of online material, and looking at how the format of educational material can best engage students. Of course, this produces increasing demand for at-home approaches to research. And this can be due to logistics during the pandemic, but also an increased demand for wider population pools, having more accessibility to more diverse data sets, and now ecologically valid studies, since we're recording data from home while people are learning at home. Remote eye tracking and facial expression analysis are really useful tools for remote research, but they each have their own caveats. And this is just due to the uncontrolled nature of collecting data from people's homes. So what this means is that you will need to think about oversampling due to decreased quality and yield of data. Of course, there's always going to be implications for privacy and data handling as well, and then also the validation of new algorithms and technology as they come out. But I think one of the papers that I cited earlier exemplified this really well when they commented that these online data approaches, or these sort of online educational approaches, are probably going to continue being used at an accelerated rate even beyond the end of the pandemic as we adopt more hybrid models, as things change with these sort of virus variants that are out in the world right now. So I think these methods of education are going to be here to stay for a really long time. And it'll be really interesting to see how our approaches to research will reflect and complement these approaches down the road. So with that, thank you for your time. Again, really quickly, we provide the iMotions software as well as access to these tools and training on top of that. We are a global company. I know a lot of you are based in Europe. I personally am calling out of Chicago from one of our US offices, but our head office is in Copenhagen, Denmark, and we also have offices around the world, Germany, Singapore, Sydney as well. So with that, I will open up the floor to questions and comments. And yeah, thank you so much again for your time today.
Thank you, Jessica. We have a few questions that came in, and one of the first questions, it has to do with the GDPR, I guess. So the question is, you talked about the cloud services of iMotions, and the question is then, where is the data collection or the data stored? Is it within the European Union? Is it US-based?
Yeah, that is a really good question and one that we get a lot. So as of today, we have servers in the US right now, and that's simply due to the US opening up at an accelerated rate and people getting back to research a lot faster. So for the moment, we have servers in the US, but of course, being a Danish company, we also fully understand the need for GDPR, and we're actively working right now to get servers established within the European Union. EU is not the only area that's interested in this stuff, especially for China. They also just recently passed a law that any sort of servers along those lines have to also be based in China. So we are sort of starting to set up servers in different areas of the world in order to best accommodate those privacy practices.
Yeah, okay, that clarifies a lot. I know that these rules are very important to follow, so it's
Absolutely
helpful to know. And then another question was about the moving in between the stimuli, because now you talked about like you have it for 20 seconds, then you move to the next stimuli. And here the question was if you can move manually between them, so self-paced and in own control. For instance, if you also want to conduct a semi-structured interview along with it, if that is also possible.
Absolutely. So we do have the option in the interface to designate either a timed transition or a manual advance. So if it's a manual advance, there'll be a little banner up top that says when you're finished, click to move to the next stimulus. So I think just for ease of collection for this sample study, we just had it be for an easy 20 seconds for everybody. But yes, we understand that, for dynamic stimuli, if you're going through, an educational page, for example, you want to be able to take your time with it, right? So we do have manual advance options as well.
Okay, and then we had a lot of questions also about the eye tracking data quality. I think you answered some of them already in the presentations with the visual degree. But another question was, you told us already that it's related or that it can be impacted by light conditions, but is there an option that the software could identify that and give suggestions to participants, like turn on your light or close the curtains to make the conditions as ideal as possible?
That is a really good idea. We do have an eye detection check. So if I actually go back to our interface here, am I sharing my screen at all? I don't think I am anymore.
Not yet, no.
Okay, let's see. See if I can share that again. Teams is being a little bit finicky at the moment. Okay, well, in that interface, while you're setting up the different conditions for your study, so there's, the microphone check, the audio check, there is an eye detection check as well, just to ensure that, checking the visibility of the respondent's eye before starting the study. We don't yet have sort of an illumination check like that, and I think that's a really interesting idea. So thank you for that. I'll actually pass that on to our product management team.
Great. And then another question about the difference between Windows and Mac. Does the module run on both, or are there some extra things to take into account when having a Mac or a Windows computer?
Yeah, so there's two sides in which I'll address that. So if you're the experimenter using the iMotions desktop platform, the platform itself is PC only, and that's because a lot of the hardware that we integrate with tend to be PC only, which is unfortunate. For those who are participants in an online data collection study, all you need is to just have a webcam, so you can be a PC user or a Mac user, all of that is fine. And in the studies that I've run, it's been a pretty solid 50-50 split between Windows and Mac users. The only difference, the only thing right now is it is only for desktop collections, so no tablets or phones for the time being. It is just desktop, but PC or Mac is fine.
Okay. And then we had a question that doesn't deal with any of the measures that we were now talking about, because eye tracking and the facial expression one, it's, I think, the easiest to collect online. But is there also some sort of way to integrate it with like heart rate measures or EEG if people have that at home? Would that be possible?
If people have that at home, that's fun. It's something that people have asked about before, especially for sort of longer studies in-house. And it's something we usually shy away from just because of the logistics. For setting up an EEG headset especially, there's just so much training and being able to put the hardware on, ensure the impedances are good before you actually go through and do it, right? So that's why for the online data collection tool, we focus on facial expressions and eye tracking, because those are the easiest to set up. For the ODC platform specifically, we don't yet have any other sensors integrated. People have asked about skin conductance before and heart rate, absolutely, and that's something we're exploring. As sort of an aside, we also have sort of a mobile platform project that's unrelated to the material today, but we're exploring ways in which we can actually have a mobile phone version of iMotions that records data from like a Bluetooth heart rate monitor, like a Polar or a Garmin, for example, and then synchronizing with other phone feeds like smartphone GPS, accelerometers, and so on. So that's like a slightly different project and a little bit of a departure, but something that we've definitely heard a lot of requests for and that we're actively listening to and trying to find solutions around.
Yeah, great. Other questions are about the data that you can extract from these kind of studies, because now you showed us a lot of aggregated data or already filtered data, but is it also possible to get like the raw eye tracking data out of it or the raw action unit data?
Yes, absolutely. Still trying to share my screen again. I was like trying to breeze through, so I didn't have the opportunity to like get into this. Teams, you're killing me. So within the software, yes, you do have the opportunity to export the raw data. What I showed earlier were ways in which you can export summary metrics, but there is an option to export sensor data. And what that'll do is give you a text file with all of the raw data logged according to timestamp. So timestamp will be a single column in milliseconds, and then all of the data from the eye tracking and the facial expression data will be synchronized in time within that document. And again, that's a tab delimited text file, so really easy to import into Excel or any other statistical program you'd like.
Okay. Yeah, we have still a lot of questions, but there is still some time, so I think that's a good sign. Then it's also a question about data quality. So are there any webcams, or does the webcam need certain characteristics to be more reliable? Do you have some suggestions there?
The great thing about the Affectiva engine is that you don't need any fancy 4K or HD cameras. If anything, having a camera that is of a higher quality will tend to bog down the system a little bit. So a simple webcam that's built into your PC or laptop works just as well. At a minimum 30 frames per second, which is pretty standard, and a minimum resolution of 640 by 480, which is pretty small. So if you have sort of a nicer webcam that comes with a more recent model, I mean, that works just as well. But the minimum qualifications are actually quite low in order to get good data. It really depends more on the lighting conditions than anything more than the camera.
Okay, and is it the same for eye tracking as well? Because you said for Affectiva it doesn't matter that much, but for eye tracking maybe it's different or not?
That's something we haven't dug much into. Just because, you know, we're sort of working with what we have with the current population. So if you have like a single webcam that you're using for facial expressions, it's not like you're going to have a better webcam on the side for the eye tracking, right? So the algorithm is really intended for webcams of a similar caliber because it's assuming that we're using both at the same time. We're using the same camera feed for both. So we haven't explored the effective higher quality cameras on that yet, but that would be a really interesting thing to get into.
Yeah, okay. And then another question, it all has to do with the quality, I guess. But yeah, the Wi-Fi connection or internet connection can, of course, be a source of problems here. But are there any laptop specification a student or a participant should need, or is it only the browser that's important here?
Yeah, because it's entirely browser-based, then it's just the browser and the webcam that really matters. So if people are recording from their laptops at home, that's also fine. You don't need any high-quality specifications there.
Yeah. And then another question is about eye tracking measures. Is it also possible to get pupil dilation information out of the webcam eye tracking?
Yeah, let's see. It's not something that we focused a lot on with this algorithm, although we've gotten requests for it. Other people have used it before, especially that case with the eye tracking in the video and relating it to the scores at the end that I showed. They used pupil data as well. We're very loath to encourage that sort of thing because pupil dilation is you have to really be stringent in controlling for light. And even in a controlled lab scenario, that's really difficult to do because any changes in illumination are also going to affect pupil dilation in addition to the arousal that you might feel, you know, while watching the material, right? So it's just really hard to get data out of it that's truly reflective of what it is that you're looking for. So it's not something that we've touched necessarily. We try to encourage people away from that. But with the infrared trackers, though, you absolutely can for sure.
Yeah, thank you. Then we have a question on the facial expression analysis, and I think it's not specifically related to online data collection, but how far is it possible with it to detect emotions while people are reading? So for textual material, because it seems to be very useful in video and watching videos, but do you know if it's also useful in text learning or text reading?
Yeah, that is a really good question. So for facial expressions, the way you have to think about it is that facial expressions evolved as a social signal, right? So what that means is that certain stimuli are going to be better at eliciting facial expressions than others. In interaction, like I'm doing with you right now, Lean, that's a really good instance where we're going to get a lot of good facial expression data because I'm emoting to you, right? It's a social signal. For videos, it is a lot of the time they're deliberately designed to elicit a reaction. So for ad testing, for example, it's a really great tool because you get to see whether a joke landed, for example. For things like text or usability scenarios, more often than not, you're going to get instances of negative affect. So a lot of brow furrow, because what usually happens in those scenarios are pain points. You get frustrated by something, you don't understand a sentence, this concept is unfamiliar to you, or you're trying to like squint and read, right? So it's not often that you're going to be smiling while you're reading something unless there's something deliberately funny in the material, you know? So I think for text, the responses might be a little bit attenuated, and they're going to be skewed more to the negative side of things, I think, depending on sort of the material that's being represented.
Okay, and then maybe a last one. It's also the last question I had here, and that's one about the algorithms used. Are the algorithms for the facial expression analysis, are they very transparent? Because the person who's asking the question experienced that there's kind of a black box around it, so it's not very transparent how exactly they are defined.
Yeah, that is definitely a difficulty. So for Affectiva, they do have some conference proceedings that have been published and that people will primarily cite. A lot of their early literature also has some accuracy measures as well, if reviewers ask about that sort of thing, and that's usually where we point people. For Affectiva, because it is a commercial product, there are some aspects of the algorithm that are not transparent and that not even we at iMotions are privy to. So, you know, there are some aspects that are not going to be available, but at least like the early citations and conference proceedings are available, and we can point you to those. For the webcam-based eye tracking, that's our own algorithm. And for us especially, we believe in transparency, especially for our research clients, because everyone has to publish at the end of the day. A lot of our analysis tools in the software are written using R, and we make the code for that freely available, as well as a step-by-step description of the methods with citations of why we did a particular thing. So I know that in these early stages, since the product just came out, we're getting a lot of demand for white papers and some sort of documentation for people to cite. That's something we are actively working on in-house, putting that together, just so our research clients have something to work off of when they're getting ready to publish.
Yeah, that's, I think, really great to have some more information about how everything is calculated. Okay, thank you, Jessica. I think we have now run out of questions and also run out of time, but I really want to thank you for providing us with a lot of interesting information and for giving the talk during the webinar. And then, yeah.
Thank you so much. And thank you everyone for participating today. It was a ton of fun, and I'm happy to answer any questions as well if people want to reach out.